There are many reasons to celebrate on December 25th. It is an annual celebration to celebrate the birth of Jesus Christ. But in astronomy, the day also marks 2 years since the launch of NASA's James Webb Space Telescope, humanity's largest space observatory. Launched on Christmas Day, 2021, James Webb is our global mission, showing the world in a new light with unprecedented resolution and wavelength for global observations. To celebrate its second birthday, James Webb delighted astronomers and recently allowed them to see a colorful cluster of distant galaxies known as the Christmas Tree Galaxy Cluster. In the cluster, the James Webb Space Telescope found Christmas lights shining in the form of 14 transiting novae, celestial bodies that glow before fading. The so-called winter wonderland is max J0416, for 0.3 billion light-years from Earth. We call max J0416 the Christmas Tree Galaxy Cluster because of the colorful and bright lights we see in it, said He Yin, an associate professor at the University of Missouri. Department of Meteorology and Astronomy, said in a statement. Transients are objects in space, such as individual stars, that suddenly brighten in intensity and fade away. These transients only appear for a short period of time before disappearing. Like watching a particle beam change themselves. Observations of many transiting objects in this galaxy were obtained in collaboration with James Webb and the Hubble Space Telescope. The number of transitions that can be found in one motion because of these two indicates that there are many things that can be found in a cluster of Christmas trees. It's like a Christmas present for astronomers who keep on giving. The moon from the Christmas Tree Galaxy Cluster began its journey to Earth when the solar system was forming. Now 4.6 billion years old, and about 300 million years old. Often the details are too small for the binoculars to see. However, a trick first discovered by Albert Einstein made it easier to see this international Christmas. In his 1915 theory of general relativity, which refers to the nature of gravity, Einstein said, objects of great mass must move through the fabric of space and time, and combined into a single entity called space and curvature as the stress we experience when an object, including light, travels through these curved regions of space. The path is curved. When an object passes between the Earth and a distant light source, the light from that background object takes a long time to reach us because the path does not follow a straight line due to the curvature created by the object. Intervene. Finally, the background object can appear enhanced from our perspective. This concept is called gravitational lensing, as the intervening object acts as a natural cosmic magnifying glass. James Webb has been tapping into this phenomenon with great success to see some of the universe's earliest galaxies, and its view of the Christmas Tree Galaxy Cluster is its latest example. In this picture, we can see many transients in certain regions due to gravitational lensing, which is magnifying galaxies behind this cluster. Right now, we have this rare chance that nature has given us to get a detailed view of individual stars located very far away, Yin explained. While we are currently only able to see the brightest ones, if we observe this long enough and frequently enough, we will be able to determine how many bright stars there are and how massive they are. The transients were found by Yin and the team as they were looking at 4 sets of images captured by James Webb over around 4 months as part of the James Webb Space Telescope's Pearls program. The team identified 2 objects in these images as supernova explosions that occur when stars reach the end of their lives. They are excited about this result because they can use these supernovae to study the galaxies out there. In addition, astronomers discovered another amazing object in the Christmas Tree Galaxy Cluster, a monster star in a galaxy that was discovered when the universe was only 3 billion years old. They named this star Matra, after the monster Matra Kaiju from the Japanese movie. The galaxy in which Matra resides is focused to 4,000 times its original brightness. The object lensing this galaxy is currently unknown, but Yin and the team estimate it has a mass between 10,000 and 1 million times that of the Sun. As Jose Diego, research lead author and a scientist at the Instituto de Física de Cantabria, said in a separate statement, the most likely explanation is a globular star cluster too faint for the James Webb Space Telescope to see directly. However, we don't know the true nature of this additional lens yet. What's extra interesting about Matra's galaxy is that it was also visible and lensed in Hubble Space Telescope images taken 9 years ago. Normally, a lensing object in a background galaxy would move out of alignment over such a period, but Mathra's home galaxy and the object lensing it seem to have stuck together. In the future, Yin and the team hope to both figure out the nature of this lensing object and uncover some of its characteristics. As Yin concluded, I will be able to understand the detailed structure of the magnifying glass and how it relates to dark matter distribution. This is a completely new view of the universe that's been opened by James Webb. One of 2 papers detailing the observation of the Christmas tree galaxy cluster was published in November in the journal Astronomy and Astrophysics, while the other has been accepted for publication in the Astrophysical Journal, with a preprint available on the research repository AR14. Notably, this James Webb shot isn't the only Christmas-themed image in space this year. Just a few weeks ago, an image of Cassiopeia, the remnant of a star that exploded 340 years ago, was unveiled by First Lady Jill Biden as part of a new White House Advent calendar. These images and others follow a long tradition of astronomers and other stargazers connecting the season of light with cosmic phenomena occurring light years from Earth. But there are real scientific surprises in some of these celebrated observations. Unlike the Christmas tree galaxy cluster, Cassiopeia A is much closer to home. Scientists have long studied constellations and other similar phenomena to understand their role in the evolution of the universe. They help galaxies grow. Danny Milovich, an astrophysicist at Purdue University who studies Cassiopeia A, wrote in an email, "Supernova remnants create the things we need to live, like the oxygen we breathe, the iron in our blood, the calcium in our bones, that at a distance of 11,000 light-years from Earth. Cassiopeia A has been seen by various telescopes in visible, X-ray, and infrared wavelengths, but the infrared telescope has a better view." Update of the website. In April, NASA released an image of the supernova remnant using the telescope's middle spectrum instrument. The new image uses Webb's near-infrared camera, which collects gas, dust, and molecules that glow in the warm atmosphere. The pink and orange structures that cover the smoky objects look like ornaments hanging from a tree branch against the bright background of the stars. Dr. Milovich says, 2 years ago, the Giftless website was launched on Christmas morning. At the time, I thought it would be the best Christmas present, but the gift that lasts is the telescope. He gave. Interestingly, James Webb isn't the only explorer to give Christmas presents. A distant star-forming nebula shaped like a turkey escaping Christmas dinner has just been captured in a new image by the European Southern Observatory's Very Large Telescope in Chile. This image shows the clouds of gas and star dust that make up the nebula IC 2944, about 6,500 light-years from Earth. IC 2944 looks like a bird, so astronomers have named it the Rooster Nebula. In a stunning 1.5 billion pixel image from the Very Large Telescope, the nebula's layers of gas and dust glow red, pink, and orange, the bright blue stars like lights on the Christmas tree. The Rooster Nebula is about 71 light-years across and is located in the constellation Centaurus. There are several distinct regions, all in a modern state, covering a 25-month climate. IC 2948 is the brightest region that appears behind this planet. This region is covered in bright gas and dust clouds, and is marked by the bright blue light of hot young stars. These stars, scattered in other parts of the nebula, cut the chicken of the sky by emitting a lot of ultraviolet radiation, which is scattered by the wind and dust, thus helping to slow down go on making stars. But some runaway regions, called box spheres, resist this energetic radiation and appear as pockets of gas, dense pockets, and dust around the nebula. Above the sky, the chicken is a vertical structure called IC 2944 that looks like a chicken wing when it flies. Above IC 2944 is the bright star Lambda Centauri, which is 470 light-years closer to Earth than the Rooster Nebula. This star is so bright that it can be seen from Earth with the naked eye. In the upper right of the image, there are 2 emission nebula regions of superheated ionized gas called the Flying Chicken's Head, VIS 39 and VIS 40.